is two rollers, and here the black one indicates black indicates these are the steel balls, hard steel balls, and other are some refractories or some ceramics or some of the metal parts. Okay, and this will be preferably operated at atmospheric this one, and these balls will be the spherical in nature. Okay, exactly circular in cross section, and you can see that once the powder which is not uniform or standard shape or size, that will be put into this, and the whole roller will be rotated. As I told you here, the two balls, those will be colliding each other. In between them, this will be, you can see this will be the powder of metal will be smashed, and it will take longer time to get to convert into a nano powder. Then once after converting into nano powder, the powder will be separated, and once again it will be sieved, and the remaining which is unsized, again once again it will be put into the ball mill so that it will be smashed once again. Okay, so this method is called the physical approach method. First beginning, it is not synthesis, it is getting the nano powder. Getting the nano powder, this is one procedure. It is also called top-down approach or high energy ball milling. High energy ball milling. And here optimized speed will be maintained, and there will be a designed speed of the speed for a particular nano powder this one, and the time required, and the ball shape and size, and the weight. All this will be mattering for a standard nano powder. And after it is rolled inside, and it doesn't mean to say that all powder will be converted to nano powder. Some of the powders may be non or unstandard size. Again, it will be sieved, and again it will be put into the roller for next. Okay, this is called the high energy ball milling or top down approach. Okay, top down approach. Next, what are the limitations of the ball mill? What are the limitations of the ball mill? You know that the plastic deformation and elastic deformation. And once due to this mechanical rotation, what happens? There will be collision of the metal particles with the steel balls and the steel balls themselves, and the inner portion of the or inner surface of the roller. There will be high temperature inside. So at a particular temperature above 100 degrees centigrade and below 200 degrees centigrade, what happens? There is a possibility that the powder will be plastically deformed. So instead of it is converted into nano powder, it will be made into a thin sheet, a micro sheet. Okay, it is not advisable to have this. So due to this, it is difficult to breaking down into required shape or size. Okay, and you know that these are the steel balls will be iron balls, and some milling tools and some atmospheric oxygen and nitrogen and some of the unwanted gases, and the worn out the milling machine itself, they'll be creating the nano powder, and that will be inserted into this, so it will be very difficult to separate them out after converting this into a nano powder. There is a possibility that they will be mixing with this the base nano powder, and this will be acting like a waste inside, and they'll be losing the properties what we expect from the nano or synthesized part. These are some of the limitations. And I was talking about the sol gel process. The sol gel process, where I was talking, just you can look into this here in the preparation, physical method and the chemical method. Under this physical method, that is the top-down approach, the top-down process or method. we have the ball milling, laser ablation, and gas condensation process. Please try to remember, it is not so difficult to portion. Ball milling is milling. Just if you want, I can show you later on in our laboratory itself. It is there. Mr. Deshpande had made this, fabricated this, and the laser ablation. The laser ablation is liberation of the particles by means of a laser. Thus, from the surface of the material in the nanopowder form, it will be liberated. That is laser ablation and gas condensation process. The gas condensation process, it is at elevated temperature, the gas will be formed and the suspended nanoparticles will be there. And once after condensing them, it will be collected. Okay, this is a simple short history about the physical methods. And under this chemical method, we have sol gel synthesis and solution pitch, that is stabilizing ligands. Okay, and precipitation method and a chemical vapor condensation method, catalytic chemical vapor deposition and template assisted CVD electromechanical method. So these are the different methods. Under them, I have taken sol gel process, and one can see this sol gel process how it is. Sol gel process here, precursor, that is the raw material will be kept here, solution of that, and hydrolysis and condensation should be made. And due to this, the hydrolysis and the condensation, after stirring, what happens? The gel formation will takes place. In the gel, what happens? The gel will be having the suspended particles of the nanomaterial. After this, the suspended particles of nanomaterials, and once after this, to remove the gel, what happens? One of the possible method is we have to go for the drying process. So for drying process, during this, and supercritical drying and evaporative drying. Supercritical drying is that totally it is dried out. For example, you say, I have taken a water in a container and heated up, and some of the water particles will be suspended along with the steam. We say the evaporative drying. And supercritical drying is that the water itself totally, which will be laying down in the utensil, it will be totally dried out. That will be supercritical drying. So there will be two possibilities. One is evaporative drying and supercritical drying. By this, and we'll get the xerogel and aerogel. Okay, aerogel is and xerogel, and both will be compounded together, and we are going to get the nanomaterial or nanopowder. It is bottom top approach. Okay, the very important steps involved: hydrolysis, the condensation, and the gel will be formed, and then we are going to do the drying. And in this drying, if it is a supercritical drying is happened, aerogel will be formed, and evaporative drying is happened, that will be xerogel will be formed, and both will be as final compounds. This will be our nano powder. It will be nano powder. It is not a synthesis, nano powder. Okay. And now, what are the advantages of these solo gel technique? We'll try to see them. What are the advantages of solo gel technique? You can see that the solo gel, the shape of the material and the complexity of the geometry, it will be suspended in the gel, cannot be easily identified. Okay, and once after it is forming a thick coating to provide the, it will be giving the corrosion protection in the next step. That means once after you are going to remove it, it will be slightly wet. What happens? There is a possibility that it will be corroded, the nanoparticle. Now, since the gel formation happened, gel will be a protective coating over this. Okay, on this. And this is a very simple and economic and effective method of producing the high quality coating. It is a very simple method. And another one among all these method of extracting the nanoparticles This is one of the simplest and cheapest method of extracting the nanoparticles. It is simply a chemical method. It is a chemical method. Okay. So we'll see the next class. We can see them. We'll stop here. Okay.